Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of the International Fuel Gas Code. My name is Thomas, and in this presentation, we are in Chapter 4, Section 402, and we're continuing our exploration of gas pipe sizing. Here's the thing. We've covered longest length method, and we've talked about the branch method in other presentations. In this presentation, we are going to examine the hybrid pressure method. Now, this is much like the longest length with some elements from the branch method, but in this method, we're using different pressures within the same system, and that affects the sizing of each of those sections at different pressures. So get out your books and let's get to work on this. In this video, we are going to be examining two examples of the hybrid pressure method. This is from 402.4.3. Let's get into it. Here are some notes on the hybrid pressure method. These are differences, set it apart from our longest length method. First of all, we have different pressures in different parts of the system, as I mentioned earlier. One or more regulators are going to be involved with this system that's going to modify those pressures. This allows for smaller and more economically sized pipe that might save some money on materials, but it also allows for larger loads over longer distances at higher pressures. So as we increase the pressure, we can decrease the size of the pipe. Now, of course, we're going to use regulators to get that pressure exactly where it needs to be when it meets the appliance. But that's overall the principle. Higher pressure, smaller pipe. We're going to use the longest length method in this. Similar to the longest length method, we use the furthest distance. So if it's from the point of delivery to a regulator, we go to the furthest regulator. Then once we've changed the pressure, brought it down to a lower pressure, we start at that regulator and we take the longest length to the furthest appliance. So those are some principles that we need to keep in mind as we get into the hybrid pressure method. Once again, we're going to follow these basic steps as we size. We're going to find the BTU per hour for all appliances. We're going to diagram the system and identify the sections that need to be sized. We'll find the developed length for each of those sections at different pressures. We'll calculate the cubic feet per hour for the sections at different pressures. Then we're going to need to select the correct sizing tables for each pressure. In this system, we are going to use different sizing tables. We've seen that as we have sized in the branch method. If we have different types of pipe, we're on different tables. Similarly, if we're on different pressures, we're going to be on different tables. It may be the same type of pipe, say steel pipe, but when we have different pressures, we'll be looking at different pages. Finally, we'll use those tables to size out the sections of the pipe. Let's start with our hybrid pressure example 1. Take a close look at this system. We are dealing with a commercial system. It has rooftop units. We look at the point of delivery, which is the meter, and at the meter there is a service regulator. That regulator is going to be set to 5 psi. That's a higher pressure for gas. It's going to be enabling this main trunk line to run at a higher pressure, and we'll see what that does for our pipe sizes. Notice that the branches going to rooftop units both have regulators. Those regulators are going to bring the system pressure down to 9-inch water column. That's something that can be used directly at the appliances. The system is using Schedule 40 steel pipe. We have 4 rooftop units. Rooftop Unit 1 at 200,000 BTUs, Rooftop Unit 2 at 150,000 BTUs, Rooftop Unit 3 at 125,000 BTUs, and Rooftop Unit 4 at 150,000 BTUs. These are all maximums for the appliance. Notice that we've taken the time to go through and label all of the sections here. We've got A through J, and we have lengths for each of those sections noted with those. So we should be able to go through, find our sections, find our lengths. We should be in really good shape. We will begin our sizing with step 1. We find the maximum BTUs for all the appliances. We saw this on our diagram, but we have rooftop unit 1 at 200,000 BTUs, rooftop unit 2 at 150,000 BTUs, rooftop unit 3 at 125,000 BTUs, and rooftop unit 4 at 150,000 BTUs. Next, of course, we diagram our system. I've already shown it to you, but when you do this, you want to draw it out. Make sure that you create your section lengths. That's where we've labeled A, B, C, and so on. And we've also indicated our lengths of those sections so that we can come up with developed lengths. We just want to really get to know the system. Step 3, we're going to find the developed length for the sections at different pressures. We have one section that's at 5 psi. That's from the service regulator to the other regulators. That covers from A to D. That's our trunk line. But we have 2 other branches here at lower pressures. So we have this section that has E, F, and G, and H, I, and J. They are each going to have different developed lengths. Have a look. If we look at section A, B, C, and D, where's the longest length? Well, it follows from A to C to D. And you know, C and D are really kind of the same section. It's a pipe with a 90. But we have different sections, different lengths, so let's just run with this. The furthest distance, though, is going to be 90 feet plus 75 feet plus 10 feet. So that means when we're sizing section A, B, C, and D, we're going to use 175 feet, and that is for that part of the system that is 5 psi. Let's look at E, F, and G. If we look at the distances on E, F, and G, we have 25 feet on E, 40 feet on F, and 10 feet on G. Let's follow the longest length. That would be E, which is 25, plus F, which is 40. That gives us 65 feet. So for section E, F, and G, when we're sizing, we will use 65 feet. Let's look at H, I, and J. With H, I, and J, once again, we're at a lower pressure. H is 15 feet, I is 20 feet, and J is 15 feet. We'll follow the longest distance. That would be H, which is 15, plus I, which is 20. We'll have a total of 35 feet. So for H, I, and J, we're going to have 35 feet for our length. Now we've got that sorted out and ready to go. Next, we need to calculate the cubic feet per hour for each section at the different pressures. Now we've expanded this table. This portion of the table are all of the sections that are 5 psi. Notice we have our developed length of 175 feet. We've got our BTUs per hour listed. If we look at the totals here, the total BTUs for the entire system are 625. We'll divide that by our BTUs per cubic foot. Once again, we're keeping this simple, staying at sea level and using 1,000 BTUs for every cubic foot of gas. That gives us a simple 625 cubic feet per hour. As we look at section B, it's only catching rooftop 1 and rooftop 2. That's a total of 200,000 plus 150,000. We get 350,000 BTUs, divide by 1,000, and we get 350 cubic feet per hour. What about section C? Section C and D are the same. They are feeding rooftop unit 3 and 4. The BTUs for unit 3 is 125,000. And 4 is 150,000 for a combined total of 275,000. And we'll divide that by 1,000 and get 275 cubic feet per hour. Now again, that's for C and D. This covers our section of the pipe that is at 5 psi. Here we have another table. This is for the sections of the system that are at 9-inch water column for the pressure. We divided that into the 2 branches, E, F, and G, and H, I, and J. Remember, these have different developed lengths. We figured that out. But now we have listed out our BTUs per hour. If we look at E, F, and G, section E is carrying both rooftop unit 1 and 2 for a total of 350,000 BTUs. We divide by our BTU per cubic foot and get 350 cubic feet per hour. And then we have our rooftop units. F is feeding rooftop unit 1 with 200,000 BTUs, divide by 1,000, and we get 200 cubic feet per hour. G is feeding rooftop unit 2 at 150,000 BTUs. We divide by 1,000 and get 150 cubic feet per hour. Check out section H, I, and J. H is feeding the 2 rooftop units. rooftop unit 3 and 4 for a total of 275,000 BTUs. Divide by 1,000 and we get 275 cubic feet per hour. Section I is feeding rooftop unit 3 at 125,000 BTUs. Divide by 1,000 and we get 125 cubic feet per hour. And J is feeding rooftop unit 4, which has 150,000 BTUs. Divide by 1,000 and we get 150 cubic feet per hour. We have it. This gives us what we need to be able to size on our sizing tables. So let's go select our sizing tables. Even though our system is steel pipe, we are dealing with different pressures. So we'll look on the table for Schedule 40 metallic pipe and then select our pressures. Here we have on table 402.47 a system that is natural gas, 5 psi, 0.60 specific gravity. So this is the table we're going to use for the higher pressure section. Then we'll use table 402.42, which is natural gas, less than 2 psi, and 0.60 specific gravity. This is what we'll use downstream of those regulators going to the units. At this point, we can use the tables, size our pipe sections. Let's get to work. Let's start with pipe section A. We have our developed length is 175 feet. We have a total of 625 cubic feet per hour. Let's go to this table. This table has our 5 psi pressure. We have 175 feet, so we will come down the left column on these rows. I'm seeing 125, 150. The next line is 175. That is exactly what we need. Now we're looking for 625 cubic feet per hour. I see 728 cubic feet per hour in the first column, and we're good. This is more than we need. So we can go to the top, and we've got half-inch pipe. We can put that on our table. But guess what? As I examine this table, look at our cubic feet per hour for all of the rest of the sections. B, C, D, they're all less than 625. So what does that mean? Well, that means everything else is half-inch. The whole main part of the system, the trunk that's carrying all the load, half-inch pipe. Not bad, eh? Yeah, that's pretty small, simple stuff to install. Very cost-effective. But once again, we're at a higher pressure. Let's see what happens when we go to the lower pressure as we feed the rooftop units. We'll size out section E, F, and G. At 65 feet, let's go on E with 350 cubic feet per hour. This time we're on a different table. This is table 2 from 402.4. It has the lower pressure, and we've got 65 feet. So follow it down. I see line 60. Line 70 is the one we'll use for our 65 feet. We're coming across with 350. So it's more than 60, more than 126, more than 237. It's less than 486. So we go to the top and we find 1 1/4 inch pipe. It's kind of a big jump, right? Here we were pushing half-inch pipe on the other part of the system, and now we've jumped up to 1 1/4. Let's see what goes to the rooftop units. We've got the same length for F at 65 feet and 200 cubic feet per hour. So we come down to line 70, coming across with 200. It's more than 126, less than 237. We'll move to the top of that column, and we've got 1 inch pipe. We'll put that on our table. So we go from 1 1/4 to 1. Let's go to G. Once again, 65 feet, 150 cubic feet per hour. Following line 70 with 150, it's more than 126. It's less than 237. We'll come to the top of that column. And once again, we have 1 inch pipe. And we'll put that on our table. So we've got that branch taken care of, right? Feeding rooftop unit 1 and 2. Let's go to the next branch. This branch has sections H, I, and J with those rooftop units. Looking at section H, we have 35 feet for our length and 275 on cubic feet per hour. We'll follow down the left column. It's more than 30. We'll go to line 40 with our 35 feet. We'll stay on this row, and we have 275. So that's more than 81, more than 170. It's less than 320. Moving to the top, we find we have 1 inch pipe. We'll put that on our table. Section I for rooftop unit 3. Same 35 feet, 125 cubic feet per hour. We're staying on row 40, coming across with 125. It's more than 81. It's less than 170. We'll move to the top of this column, and we have 3/4 inch pipe. We'll put that on our table. Then we have rooftop unit 4 with J, 35 feet, 150 cubic feet per hour. Coming across on line 40, it's more than 81. It's less than 170. So we'll go up and we find, once again, 3/4 inch pipe. That should do it. We've sized everything on this system. We're going to run 1/2 inch for everything from the meter to the regulators. And then we've got anywhere from 1 1/4 to 3/4 on these branches leading to the rooftop units.
Nice work.
All right, let's check out hybrid pressure example 2. This hopefully looks familiar. We used this diagram on our branch length method. This is a residential system. It's using CSST for everything. The only difference between this and what we looked at before is that we have a higher pressure from the meter to the manifold. We're going to use 2 psi at the meter. And then at the outlet of that regulator, we'll have it down to 8-inch water column. So just section A is going to be at higher pressure. Everything else will be at that lower pressure that we've dealt with before. Here's our list of appliances. The furnace has 80,000 BTUs, water heater 36,000 BTUs, the range has 52,000 BTUs, the dryer has 28,000 BTUs, and the room heater has 25,000 BTUs. We take the time to diagram our system, label the section lengths, A through G, and we're going to find those distances for each one. That gives us enough information to figure things out. Let's put our sections on the table. Here we have section A, and we're looking for developed length. If we look at the diagram, it's 45 feet from the meter to the regulator. That's all we have to do. A lot of these are similar, right? Branch B is 15 feet. Branch C is 10 feet. Branch D is 20 feet. So we'll use each of those lengths on our table here. But with branch E, F, and G, if we look at E, it's 20 feet, and both F and G are 5 feet. For each of those, we're going to add those distances, and we'll use the total length of 25 feet for those. The next step is to calculate for the cubic feet per hour for all of those sections. Let's expand our table. Section A has a total of 221,000 BTUs. That's our higher pressure at 2 psi. We'll divide by our 1,000 and get 221 cubic feet per hour. The branches, branch B, 80,000 BTUs, so we get 80 cubic feet per hour. Branch C, 36,000 BTUs, we divide and get 36 cubic feet per hour. Branch D, 52,000 BTUs, we divide and we get 52 cubic feet per hour. Branch E, we've got 53,000 BTUs, we divide and get 53 cubic feet per hour. Branch F, we've got 28,000 BTUs, we divide and get 28 cubic feet per hour. And branch G, we've got 25,000 BTUs, we divide and get 25 cubic feet per hour. That completes our cubic feet per hour list, and that means we're ready to go do some sizing. But before we do, we need to make sure we have the correct tables. Focus in on system information. Once again, from the meter to the regulator, we have 2 psi. From the outlet of the regulator to the appliances, we have 8-inch water column. This is natural gas, specific gravity of 0.60. All of it is CSST, as I mentioned. So let's go select our tables. We get into 402.4. Table 18 gives us CSST, and it gives us the natural gas 2 psi. That's the one we'll use for the trunk line. 402.4, table 15 gives us CSST, but now it's at the lower pressure, downstream from the regulator, less than 2 psi, natural gas. This is the table we'll use for the rest of it. Let's use the tables and size this thing out. Let's start with section A. Remember, we're on 2 psi, 45 feet with 221 cubic feet per hour. If we go with 45 feet, come down the left column, it's more than 40. Let's go with line 50, and we have 221 cubic feet per hour. So we're coming across, it's more than 154, it's less than 266. We'll come to the top and we find we have the tubing size of 18. So we'll put that on our table. From here we go to lower pressure. We've got branch B with 15 feet and 80 cubic feet per hour. This is everything downstream from the regulator and branching off of the manifold. So if we have 15 feet and 80 cubic feet per hour, we have a line 15 here. Let's take that, come across with 80. It's more than 66, more than 77. It's less than 132. So we come to the top and we find a tubing size of 23. We'll put that on our table. How about branch C? Developed length, 10 feet, cubic feet per hour, 36. Branch C is the one that's feeding the water heater. We have a line for 10 feet and we've got 36. It's more than 32. It's less than 44. We'll come to the top here and find a tubing size of 15. We can put that on our table. Branch D, 20 feet of developed length with 52 cubic feet per hour. Branch D is going out to the range. We have 20 feet, so there's line 20 and 52. It's more than 31, but it's less than 58. So we'll go to the top and we find we have a tubing size of 18. We can put that on our table. Next we have branch E. This is feeding both the dryer and the room heater. The length for branch E is 25 and the cubic feet per hour total is 53. There is a row for 25 feet, so we'll use that row coming across with 53. Oh, look at this. It's more than 52. So we've got to bump to this column that has 60. We'll move to the top and find that we have a tubing size of 19. So we'll put that on our table. Now we have branch F. We have 25 feet and 28 cubic feet per hour. F is going to the dryer. 25 feet. We do have a row for that, and 28. Oh, look at this. It's more than 27. We're going to have to bump up to this column that has 52 cubic feet per hour. Go to the top and we find we have a tubing size of 18, and we'll put that on our table. Last one, branch G, 25 feet with 25 cubic feet per hour. This is the line running over to the room heater. We have a line 25 and 25 cubic feet per hour. That's more than 19, less than 27. Come to the top and we find we have a tubing size of 15, and we will put that on our table. We have completed it. Now, we looked at this in the branch length method, but tubing sizes for CSST are not in inches. And that might be a little confusing, but manufacturers produce those with EHD, or equivalent hydraulic diameter, tubing sizes. This table, as I've mentioned before, is an estimate. You'll want to check with the manufacturer of whatever CSST you're using for more specifics about sizes. But really, you can run with these number sizes. For your information, these are the comparables, and this is approximated. You have 3/8 is about 15 EHD. If you're looking for half-inch pipe, that's 18 to 19 EHD. 3/4 is 23 to 25. 1 inch, 30 to 31. 1 1/4, 37 to 39. 1 1/2, 46 to 48. And 2 inch, 60 to 62. That's your rundown on the EHD sizes. Really, you should be able to go and order according to these sizes and get your whole system put together. Now we've sized out both systems. All right, that does it for our examination of the hybrid pressure method. Hopefully you can see where the principles from longest length and branch length methods apply here. Then we're dealing with different pressures and different tables, but this is how we size this out. This is really useful. A lot of installers will do this. Increase the pressure, decrease the pipe size over a long distance, and then use regulators to get it right where we need at the appliances. It's a great way to install. Now, all of these sizing methods that we've looked at, including longest length, branch, and hybrid, have been simplified by the fact that we're using 1,000 BTUs per cubic foot of gas. That's great if you're at sea level. If you're not at sea level, you have to know how to derate, because you're not going to get 1,000 BTUs per cubic foot at 4,000 feet. So in the next presentation, we'll look at how deration works. That is the sizing method that you really need to pay attention to for field work, for field sizing. So you can look forward to that. I'll see you in the next one.